Okay, so for example 11, we're going to graph f of x equals x squared minus 2x plus 6 by algebraically determining the key features, and then state the domain and the range. So you might start to think about, well, what are the key features of the graph? What do we need to do in order to get those key features? So the key features that we want to find are going to be the y-intercepts, or y-intercept, there's only one, the x-intercept, the vertex. Okay, so the y-intercept, we can identify that pretty much right away. And so if I look here, I'm going to say, the y-intercept. If I plug in f of 0, the only thing left is 6. So my y-intercept is 0, 6. Now I notice that this is opening upward because a here is equal to 1. When a is positive, then our parabola is opening upward. Well, if my y-intercept is all the way up at, and I don't have a ruler on my tablet, I bet there was a way that I could draw a line, but anyway, if my y-intercept is all the way up at 0, 6, 1, 2, 3, 4, 5, 6, and right here, this is my y-axis, my x-axis. What I'm doing when I'm putting the numbers in here, 1, 2, 3, 4, 5, 6, is I'm indicating what my scale is that I'm using. And then labeling my axis is important. Here's my first point, the y-intercept. If my parabola is going to face upward from here, it's not going to have any y-intercepts, right? Because it's not, or sorry, x-intercepts, because it's not going to cross the x-axis. So I can determine that there's none. There's lots of other ways that you can actually determine that there are no x-intercepts, but you know, like you could do the quadratic formula, you could try to factor it and set it equal to 0. Because remember that when you're finding the x-intercepts, you're setting f of x equal to 0, and you want to solve for x here, okay? And then here I'll use the same scale, 1, 2, 3, 4 on my x-axis, and then you can put in some negative numbers too, -1, -2. And then for the vertex, there's lots of ways I can find the vertex. There's formulas for that as well. I could use part of the quadratic formula, which is x equals -b over 2a. But we've been learning to complete the square in order to put it into a vertex form. So in order to complete the square, I'm going to set it up as f of x equals x squared minus 2x. And then I'm going to put the plus 6 over off to the side. So I'm going to want to balance this out so that I can make a PST, a perfect square trinomial, and I'm going to be adding something here. And in order to balance that out, I want to subtract the same amount. So whatever I add, I also have to subtract, so that essentially I'm just adding 0, right? So let's think about what would make this a perfect square trinomial. Well, it would have to be half of this number squared. So I take my b, which is -2, I divide it by 2, and then I'm going to square it. So I get -1 squared, which is a +1. Since I'm adding 1 here, I have to also subtract 1. Okay, and maybe I put that work a little bit off to the side since it's getting in the way. So essentially, we're always going to take b divided by 2 and then square it to get whatever we're going to include for our c there. I mean, I'm adding c. So now I can factor that. That factors down to x minus 1 squared because it is a PST. And then I can simplify this side and I get plus 5. So that tells me that my vertex is 1, 5. So if I go back over here, 1, 5 is here. And then I don't have any x-intercepts. I only have 2 points so far. But I know there's symmetry. I know that the vertex represents the minimum value, the minimum point on the graph. So it's a turning point. And since there's symmetry, there's actually an axis of symmetry. The axis of symmetry is going to be x equals 1. So that's going to cut my parabola in half. Therefore, I know there's a symmetrical point right over from 6, and it has to be 1 unit over because that is 2, that point would be 2, 6. Here we have 0, 6 is my y-intercept, and my vertex is 1, 5. So from there, those 3 points, I could draw my parabola. Now, if I wanted to find more points, I was talking about maybe previously, just the pattern of perfect squares, okay? So when you think about taking a number and squaring it, if I start with the number 0 and I square 0, I get 0. If I square 1, I get 1. If I square 2, I get 4. If I square 3, I get 9. If I square 4, I get 16. So these are what we call the perfect squares. When you have a here equal to 1, you are going to get this pattern of, it's not quite rise and run. A lot of times people want to say, we only use rise and run for lines. But for here, it's going to be when your x is 1, if you start out at the middle place here, you're going to go over 1, up 1, because that's the 1, 1. If you go over 2, x is 2, well, in this case, x is 3. But just from that basic pattern, if I go over 3, I'm actually going to go up. Or sorry, if I go over 2, I'll go up 4. And if I go over 3, I'll go up 9. And so you kind of can see that pattern working on your graphs. And you might just play around with that on Desmos. And it's, by the way, it's totally fine to graph these using Desmos and check them. That I do not consider cheating, because I want you to use Desmos. Desmos is our free graphing calculator. Of course, you want to be able to do all of this by hand. You need to be able to find the key features and then, you know, be able to graph it by hand, but feel free to verify that, you know, using Desmos as well. Okay, so that's graphing a parabola. Yes.
What would be the range for this?
The range. Oh, good. I'm glad you brought that up. So the range is the y values. The domain is always going to be, for any parabola, the domain is going to be negative infinity to positive infinity, because you can plug in any value of x. There's no restriction, right? There's not going to be any problem. If you plug in any value of x, it's not going to give you any kind of wonky answers. You're not going to get 0 in the denominator and things like that. The range is always going to be the smallest value to the largest value when it comes to the y values. So the range are the y values, and from that would go from the smallest y value is 5, and we can include 5. And since this parabola is opening upward, we put arrows on the end, and that's going to go on for infinity. So from 5 to infinity, and that would be the range. Good, very good question.